This is the front of the grid worksheet, and I'm going to start with line number 1. I'm going to expand this so it's a little bigger here. And first we're going to write our formula for ammonium oxalate. Ammonium oxalate has a formula of NH4 2C2O4. This is a formula unit. And this is an ionic substance. So far, I don't know if my highlighter works here. These are the 3 things that I've answered so far. Now let's move over to molar mass. To solve molar mass, we're going to write down, each one of our atoms that we have, N, H, C, and O. I'm going to write the quantity for each. I have 2 nitrogens, we have 8 hydrogens, 2 carbons, and 4 oxygens. Each of these we will multiply by the molar mass. Remember, we always round our molar masses to 2 decimal places. The periodic table I gave you has most of the elements already rounded to 2 decimal places. Then we add these together. And let me grab George's calculator, which I'm using. 28.02 plus 8.08 plus 24.02 plus 64 equals 124.12. And the units for molar mass is grams per mole. It's not very pretty. Grams per mole. Next, you can see that we are given moles and asked to convert to mass, and we are asked to convert to representative particles. In this case, the representative particle is the formula unit. So this is going to be pretty simple. To convert to mass, we're going to convert moles to mass using our molar mass. So we will be taking, let me make this a little bigger so it fits. We'll be taking 6.40 moles times, and it's from our molar mass column, 124.12 grams per mole. I get 794.368, and rounding this to 3 sig figs, our answer will be 794 grams. Next, we're going to convert to formula units, our representative particles. And here we will do this by converting mass to representative particles using Avogadro's number. And I will do that by taking my 6.40 moles times 6.022 times 10 to the 23rd formula units per mole. And this equals 3.85 times 10 to the 24th formula units. always, my tail always gets too big on these. Times 10 to the 24 formula units. Now for our next one, our next part, when we're doing total atoms, we need to look at these numbers that I have right here. Whoopsie. These numbers that why can't I get my yellow here? And if I add those up, these numbers will tell me how many pieces I have. I can see that I have 10 plus 6. This, got the wrong one. Means I have 16 atoms per formula unit. So I'm going to multiply my answer. I'll need more room here. From this problem, 3.85 times 10 to the 24th formula units times 16 atoms per formula unit. So I'm going to take my 3.85, and I didn't round this, so I'm going to get 6.17 times 10 to the 25th atoms. Our next piece that we're going to do is right here, and we are given Li2CrO4. This is lithium chromate. It is ionic, and my represented particle is the formula unit. I have lithiums, chromiums, and oxygens present. 2 lithiums, 1 chromium, 4 oxygens. Lithium has a molar mass of 6.94. Chromium is 52.00. And oxygen is 16.00. And the 6.94 times 2 is 13.88. So we have 13.88 plus 52 plus 64 is 129.88. For reference, let's notice, why do I have trouble changing these? That I have 2, 1, and 4 for a total of 7 atoms per formula unit. Now note in this that we are given grams. So the first thing I'm going to do is go to formula units, because that's going to be a little bit more, an extra step. I could go to moles first and then use that answer and then go to formula units, but I'm going to do this. I'm going to go from grams to moles to representative particles. And in order to do this, I got to go over a little bit further, make it a little bit bigger. See if I can make this work on here. I'm going to take my, I'm going to actually steal a little bit of this. I'm going to steal this much of this. 2.68, whoops, 268.45 grams times 129.88 grams per mole times Avogadro's number. Move over a little bit now. Representative particles per mole. This will equal 268.45 times 6.022 times 10 to the 23rd divided by 129.88. and I've got to go to 5 sig figs, so I'm going to get 1.2447 times 10 to the 24th formula units. Next, let's do moles. And from moles, we're simply going to go from grams to moles. And I'm going to cheat a little bit and just circle this. This part of this will give us our answer. 268.45 divided by 129.88. And that gives me 2.0669 moles. Now, whoopsie, let's go over to this one and do a green. To find my number of particles, please recall that there were 7 atoms per formula unit. So if I take this number times 7 atoms per formula unit, I get 8.7129 times 10 to the 24th atoms. Okay. Next, we're given aluminum hydroxide, which is AlOH3. This is also ionic and a formula unit. We have AlOH, 26.98 times 1, 16.00 times 3, and 1.01 times 3. Let me add these. 26.98 plus 48 plus 3.03. Enter. 78.01. And I can see by looking at the numbers that I'm about to highlight that I have 7 atoms per mole. Or per formula unit. Please note in this problem we are given formula units. And I'm going to do this one first because that's going to be basically the opposite of what we just did. We're going to go from formula units to moles to mass. I'm going to start this here, and I'm actually going to take most of this. I'm going to take this whole thing for this. So I have 3.61 times 10 to the 21st formula units. Our first order of business will be to use Avogadro's number to convert formula units to moles. And then we will use our molar mass from right here to convert moles to mass. 3.61 times 10 to the 24th divided by Avogadro's number multiplied by 78.01 is 1.695. So I get 1, I did something wrong. Oh, I multiplied. 3.61 times 10 to the 21st divided by Avogadro's. There we go, times 78.01. So here I get 467.645, and rounding this to right sig figs, I get 468 grams. Now, to get our moles, we're just going to go from formula units to moles, and that will be, I'm going to cheat a little bit again, it'll be just what I've circled right there. And that'll be 5.99468, and that'll be 5.99 moles. Let's recall that we had 7, so I'm just going to take, for our last part, we're going to take this number, if that number of formula units, by 7 atoms per formula units. That'll be 2.53 times 10 to the 25th atoms. Okay, now we're going to go down to our next page. Got to get smaller here. And we're going to do number 9. So number 9 is carbon monoxide. This is a molecule. Its molar mass will be 12.01 plus 16.00 is 28.01 grams per mole, and I'm given moles. So this is the one that I'm most concerned with here. In order to find this number, let's make this one blue. We're going to convert from moles to volume using 22.4 liters equals 1 mole. So we'll go 11.688 moles times 22.4 liters per mole. This can be reported to 5 significant figures. So I will have 261.81 liters. Remember, this is for gases at STP only. And this one's pretty simple. For this one, for representative particles, you're going to take this number times Avogadro's number. I'm not going to do this one for you. And for mass, you're going to take this number, oopsie, there we go. We're going to take 11.688 moles times 28.01 grams per mole. Report your answer for both the red one and the blue one to 5 sig figs. And here your units should be 5 sig figs. Okay, done.